there. Today we're going to talk about percents. And first I want to talk about what a percent means. You know, we've been doing a lot of ratios, and when we talk about a ratio, for example, something like 1 to 4, we have 1 of something compared to 4 of something. This line, meaning per, was 1 per 4 of something, right? Or a ratio of 1 to 4, right? So when we're talking about percentages, we're talking about what percent that is, all right? And as we all know, 1/4 is 25%. But the word percent, or this symbol right here, see how it has a line here? This symbol actually means per 100. That's why we use the symbol that we do, right? So we would say there were 25 per 100. And actually, doesn't that make sense? That if there's 1 per 4, that there'd be 25 per 100. Those are equivalent fractions or equivalent ratios when we would say 1/4 is equal to 25 hundredths. They're equivalent. So a percent has to do with the ratios that we've been doing up to this point. So it's important to know what that means. What do we mean when we say percent? Cent means 100, just like a century, right? Or we call 1/100th of a dollar, we call it a cent, right? A penny is a cent. So, for example, if we had something that was 12%, okay, then what that means is it's 12 out of 100. That's what that means, okay? And we have that symbol there. So a percent is a ratio. We're comparing a number to 100. For example, you could have the fraction of 5/10, which we all know means half, right? But if you had a fraction of 5/10, this is writing that ratio as a fraction. Then in a decimal form of 5/10, since the 5 would be in the tenths place, is 0.5, right? Which, by the way, is the same as half, right? 5/10 equals 1/2, right? And 1/2 we represent it as 0.5 because we put a 5 in the tenths place. Okay, so we would write the fraction like this, 5/10. We would write the decimal like this. And a ratio would we would say 5 out of 10, right? Or we might say 5 to 10 ratio, okay? But they all kind of mean the same thing. The fraction 5/10 means half, 0.5 is half of 1, 5 out of 10, 5 would be half of the 10, right? So that ratio would be there. So we can write decimals as fractions, as you can see right here, right? That we can write decimals as fractions. So for example, if we had a decimal of 0.16, we would write that as a fraction by taking that 16, and underneath on the bottom of the fraction, we'd write what place value it is. So this is 16 hundredths, so that would be written as 16 hundredths, okay? Or for example, 0.28, that's 28 hundredths. So we would write it 28 hundredths, or 28 over 100, okay? Look at something like 3/10. Okay, that's 3/10. Okay, we write a 0.3, that's 3/10. So that would be equal to 3/10 as a fraction. Or if we wanted to make it out of 100, you'd just add that 0 because that 0 would be in the hundredths place, so it's 30 hundredths. So see, 3/10 is equal to 30 hundredths. It's the same thing if you had something like 2/10, right? So 2/10 can be written like this, or it could be written 20 hundredths. That means the same thing. Okay, so let's kind of talk about what we're actually doing here, okay? So let's say there was a race car that uses 2 gallons of gas to travel 25 miles. So how many miles can it travel on 8 gallons of gas? If it's 2 gallons for 25 miles, we'd write that as a ratio, right? And then we would say, how many miles would it travel on 8 gallons of gas? Well, wouldn't we just make a ratio and then we'd say the 8 gallons on top, and we'd have X down here. We'd want to know how many miles it could travel, right? So writing these ratios makes things really handy and convenient to be able to look at and see what to do. We already know 2 times 4 is 8, so we do the same thing to the bottom, right? So yeah, so it's, you know, and we could do it this way, or we could even write it as, like, say 25 miles per 2 gallons. We could write it like that, which is just a divide, right? So in this case, we would do 2 gallons. To make that 8 gallons, we'd do times 4, and 25 times 4 would equal 100. So our X would be 100. Make that on the page there, sorry about that. Then our X would be 100. Here, if we said 25 miles per 2 gallons, you could actually just take 25 and divide 2. If you did 25 divided by 2, you'd get 12.5. And 12.5 would be how many miles per 1 gallon. That's a base unit rate. That's a unit rate right here. That's our unit rate. And so then we could go ahead and turn that into 8 gallons, which of course 25 times 8 is 100. So different ways to do this, but it's all the same thing. But can you see how those ratios help us to figure it out? Okay, so that's kind of what this week's math is a little bit about, but we're going to go a little bit deeper now. So let's talk about a survey that maybe says 13 out of 20 people have pets, okay? So if a survey said 13 out of 20 people had pets, let's write that as a ratio, okay? And maybe the question would tell us to write the ratio as a percent, okay? So we'd say, all right, 13 out of 20 people have pets. And if we are gonna write this as a percent, do you know what we want? We want 100 on the bottom, don't we? Because percent means per 100. If we have per 100, we have the percent. Okay, so let's say we have 13/20ths, because we're saying 13 out of 20 people have pets. So we're gonna write this as a percent, this ratio as a percent. How many people have pets? Well, to get 20 to be 100, you'd times 5, right? 20 times 5 is 100. Whatever you do to the bottom, you do the top, because ratios act exactly like fractions in math. They act exactly like fractions. So we would need to do the same to the top and bottom. Well, 13 times 5 is 65. So that would mean that 65% of people in this survey have pets. We took our ratio and we made it into a percent by figuring out how many it was per 100. Another example would be, say we were doing pie crust, okay? And we had maybe 1 cup of sugar per 4 cups of flour. Okay? So if we had 1 cup of sugar per 4 cups of flour, it would look like this as a ratio, 1:4, right? Of course, you can write it in many ways, but we like to write it as a fraction because that will work the same way a fraction does when we do math. To figure out what percent that is, we would just make that equal to a ratio that has 100 on the bottom of it, okay? Well, we know 4 times 25 is 100, so we'll just do the same to the top, and so 25 hundredths is equal to 1/4. And doesn't that make sense? Now, another way to do it is to understand what this means. This line means divide. 1 divided by 4. That's what this line means, divided by 4. Well, let's see, what's 1 divided by 4? We could actually just do the problem. So one way to do it is to figure it out by doing a fraction with 100 on the bottom. That'll give you the percent. Another way to do it is to just go ahead and do the division problem. 1 divided by 4. We can totally do this, we know how. 4 does not go into 1, but 4 does go into 10. Excuse me, it goes in twice. 2 times 4 is 8. When we subtract that out, we get a 2 on the bottom. Bring down the 0. 4 goes into 20 5 times, and it comes out evenly. Okay, so we get 0.25. That's the decimal form of 1/4. Okay, which makes sense. That's 1/4. And in money, 25 cents is a quarter. That's why we call it that. Makes total sense. When you're changing a decimal into a percent, what you're going to do is move the decimal over 2 places. Do you know why? The reason why is because this 25 right here is, with the decimal here, is in the hundredths place. That's the hundredths place. Now we're saying per 100, so if this is in the hundredths place, that fraction looks like this. Or that decimal, sorry, well, the fraction of the decimal. This decimal looks like this as a fraction. So see, you can actually do it both ways. All right, let's take it a little farther, okay? Let's start to apply what we know a little bit here. Let's say there was a chili cook-off, and 18 of the 40 chilies included 2 types of beans. This might sound familiar because it was in one of our lessons, okay? I'm taking these problems from our lessons in class. 18 of the 40 18 of the 40 chilies that were in this chili cook-off had 2 types of beans. So what percent of the chilies did not include 2 types of beans? So let's look at this. 18 of the 40 had 2 types of beans. The question says, what percentage of the chilies did not include 2 types of beans? In a question like this, the first thing we have to do is figure out which ones did not. This is how many did have 2 types of beans. So we're going to take that 40 and minus out 18 and find out how many did not have 2 types of beans. Well, 40 take away 18 is 22, okay? So we're going to take that 22 and we're going to say 22 out of the 40 did not have 2 types of beans in it, okay? Now we have a number to work with. So you can do this a couple of ways, but you know what we'd probably want to do is go ahead and write it as a ratio that looks like a fraction, okay? So why don't we come back up here and why don't we go 22 out of 40, right? 22 out of 40. And what we want to do is turn it into a percent because it's asking us what percent, so we're going to go per 100. To make it a percent, you want to go per 100, okay? So we can't really multiply 40 times anything to get 100, but there's a couple ways we could do this. You could just pop zeros on the end of both. That's multiplying it both by 10. Now you can just divide 4 top and bottom, right? That's one way to do it. I like to just make an equivalent fraction. You know, I know 20 would go into 100, so what if I did 11/20ths? That's an equivalent fraction, right? If I did that, that's pretty easy to do. I just times 5 here and times 5 here, and I get 55 100ths, and that means it's 55%. Oops, 55% of the chilies did not have 2 types of beans. There's also another way to do it, okay? So the other way, and I've told the class this so often, is if you cannot figure out how to do it, just divide, okay? 22 divided by 40 will also give you the answer. This line means divided by, so if you just divide it, you're gonna get the right answer, okay? It's gonna make it a decimal, and then we have to make it into a fraction, into a percent. So let me show you. So you can do this a couple ways. You know, if you know an equivalent fraction is 20, you know, you could do 20 divided by 11, or sorry, 11 divided by 20, and that would work too. We're gonna pop some zeros on here. 40 does not go into 22, so we're gonna put a 0. But 40 does go into 220, and it, I believe, would go in 5 times, okay? So because 5 times 4 is 20, so that would make this 200, okay? And then we would subtract that out and we get another 200 once we bring the 0 down, and again it's 5. And we get 0.55, or 55 hundredths, okay? This fraction, we do have to make it into a decimal. This is 55 per 100, so we write it like this, 55%. And the same thing here. This is 55 hundredths, so we write it as a percent like this. We move that decimal over 2, because the reason why we get rid of the decimal is because, well, we don't get rid of it, we move it over 2. This is the hundredths place, okay? If this answer somehow was like this, it's not, this is not the correct answer, but if it had another number here, then we would move the decimal over 2 places, and then our decimal would have a percent if that happened. So that sometimes happens, but in this case, that's not the right answer. The answer is 55%. So let's take it even farther. Say there's a football game, and Marcus completes, I'm reading it out of the book. Marcus completes 3 out of 4 pass attempts, okay? 3 out of 4 is Marcus, okay? And then let's say Terry completes 7 out of 10. And in the book, it writes it like this. Marcus completes 3 out of 4 attempts. That's how it writes it in the book. And Terry completes 7 out of 10. That's how it says it, 7 out of 10. Okay. When I wrote it onto the board out of the book, I immediately wrote it like this. Now, if you get 2 ratios like this, of course we know methods like the butterfly method, where we could put them next to each other and do a butterfly method and figure out which one was larger. And then that would tell us who has the better record once we know which one was larger, which one was smaller. But let's do it the way we're talking about here, okay? 3/4. You can do this a number of ways, but you know, one of the ways, I know that that's 75%, right? Because I know 75 cents is 3/4. Like, I know that in my head. But we could do it by saying 3 divided by 4, okay? 4 would go into 30 7 times, okay? 7 times 4 would be 28. You'd bring down the 2 and bring down another 0, and 4 would go into 20 5 times. That's 0.75. But look, 7/10, yeah, you could go through and divide it. You could say 7 divided by 10, but when you got done, wouldn't you just end up with 71 hundredths or 70 hundredths? This is already 7/10. 7/10 is written like this, 7/10. To put it in the hundredths place, you just pop a 0 on there. So you can tell that Marcus did better. He got 75%, where Terry only got 70%. Okay. The final one I want to show you is about a fundraiser. So Liz is collecting cans for a fundraiser, and let's say she's collected 16 cans so far. Okay. And the 16 cans is 20% of her goal. Okay. So she's got 16 cans, that's 20% of her goal. How many cans must she collect to reach her goal? This is a great question, okay? She's already collected 16 cans, and that's 20% of her goal. How many more cans does she have to collect to reach her goal? This is actually a really easy problem. You can use a ratio to solve it. Every 16 cans, she's at 20% of her goal. That means that when she's at 40% of her goal, that's going to be 32 cans. And when she's at 60% of her goal, that's going to be 48 cans, right? And when she's at 80% of her goal, that's going to be 64 cans. And when she gets up to 100% of her goal, that's 80 cans. Cool, huh? This is like those tables they always show us in math, right? When you put a chart and then you fill it in and fill in the patterns. For every 16 cans, that's 20% of her goal, so you just add it up. Another way is to do it like a ratio. So you'd say, all right, every 16 cans, she's 20% of her goal. So what would that be if for 100% of her goal? And look at that. That's easy. You can solve that easily, right? What's this number? Well, 20 times 5 is 100. 16 times 5 is 80. Hopefully that helps you with this week's math, and we'll see you next time.